All right, section 5 of chapter 1 deals with angle pair relationships. One of the things that we're going to talk about in geometry are different angles, much in the same way of section 4 of chapter 1 we dealt with angles. We're dealing with two special types of angles now, complementary and supplementary angles. And these are two identities that will carry through the rest of the year. You'll have to kind of remember these. But they're very, very simple. Complementary angles are two angles that add up to 90 degrees, meaning their angle measures add up to 90. Maybe one of them is 30 and 60, or 45 and 45, or 40 and 50. Either way, they add up to 90 degrees. Two angles that add up to 90 degrees are complementary. We say that angle 1 and angle 2 are complements. If they're complementary, then they're complements. Supplementary, two angles that add up to 180. Again, maybe it's 150 and 30, or 120 and 60, or even 180. You get the idea. Two angles that add up to 180. If they add up to 180, we call them supplements. Their angle measures are supplementary, and the two angles are supplements. Understand that complements means 90 degrees. Supplements means 180 degrees. Do angles have to be adjacent, meaning do they have to be right next to each other? The word adjacent means next to each other. Do they have to be adjacent to be supplementary or complementary? If I have an angle over here that is 60 degrees and an angle over here that's 30 degrees, can those two be complementary? And the answer is yes. They do not have to be adjacent. No, they don't have to be adjacent. They can be separate. If angle 1 and angle 4 add up to be 90 degrees, then I could say they're complementary. If angle 2 and angle 3 are supplementary, I can call them supplementary. They don't have to be right next to each other. Adjacent means next to each other. Okay? Those two identities, the complementary and the supplementary, are pretty important. Identify two pair of complementary and supplementary angles. Let's go through right now and identify the complementary first. And we'll label those in blue. Two angles that add up to be 90 degrees. Well, the first thing that we should see is this guy down here. This guy is already 90, so we can't use him. Okay? We can't use him. We're just identifying the complementary first. Let me write complementary right below that. That way we kind of recognize 90 degree and complementary as the same. Let's just go through angle by angle. This angle here is 122. We're dealing with 90 degree angles, so we can't use this 122. But what about 32? We can use 32 because it's less than 90. Now we need to figure out, is there an angle out there that can add up with 32 to reach 90? Well, it would have to be a very specific angle. We would have to, if we're using 32, we would have to use 58 in order to get 90. Is there a 58 out there? The answer is yes. If we use this angle, we can also use this angle. Those two are complementary. Okay, what else? Let's look at this guy. 68. Can we use 68? The answer is yes. But if we were to use 68, we would have to find a 22 degree angle to use with it, because 68 and 22 add up to be 90. But we don't have a 22 degree angle out here, so we can't use him. Let's go to the next one. 131. Well, we're trying to deal with two angles that add up to 90. He's already too big. But what about 41? Yeah, we can use 41, but if we're dealing with complementary and we have an angle that's 41, another angle we would have to use is 49, because 41 and 49 add up to be 90 degrees. 41 and 49 are complementary. We're in luck because there's a 49 right there. So we have two pair. We have one over here, 32 and 58, and one here, 41, 49. Now let's go through and try and identify supplementary angles. I'm going to erase these little addition marks because they helped us identify supplementary or complementary angles. Now we want to try and identify supplements, things that add up to 180. Again, I'm just going to go clockwise. 122. Now, I couldn't use it for complements, but I can use it for supplements. If I want to use it for supplements, I need to figure out what other angle it would work with. 180 minus 122 gives me 58 degrees left over, and I can say that 122 and 58 are supplements, meaning 122 and 58 add up to be 180. Well, I'm in luck because right here, there's a 58-degree angle. So these two red ones, or angle CAD and angle RST, are supplements because they add up to 180. We just proved that right over here. Let's keep going. What about 68? Well, in order to use 68, we would have to have a 112-degree angle. I don't see a 112-degree angle anywhere in here, so 68 does not have a supplement on this page. Let's keep going. 90. If we take 90 from 180, we get 90 left over, meaning that 90 and 90 are supplements. I don't see another 90-degree angle here, so I can't really say that this has a supplement. So we just keep going. I'm going to grab this big one, 131, and I'm going to say, all right, if I take 131 degrees from 180, how much do I have left over? 49. That means that 131 and 49 degrees are supplement. Well, I'm in luck because here's my 131 and here's my 49. So they are supplementary. I identified two pairs of complements that are blue and two pairs of supplements that are red. And all this is just testing your addition, to be honest. Can you find two things that add up to 90? Can you find two things that add up to 180? Very, very simple stuff. A linear pair. A linear pair are two adjacent angles. A couple minutes ago, we talked about angles not having to be adjacent to be supplementary or complementary. Now we're saying a linear pair are adjacent angles, meaning they share a side. You can see right here that angle 1 and angle 2 share a side. A linear pair is basically, let me rewrite it in a different color. They're supplementary angles. That are adjacent. So we can have supplementary angles that aren't adjacent, and in this case, if we have supplementary angles that are adjacent, they have a special name. They're called a linear pair. And a note, what other geometric property do linear pairs look like? And the answer is supplementary angles. That's because a linear pair is a supplementary angle, or two supplementary angles, excuse me, that are adjacent. Okay, again, supplementary don't have to be adjacent. But if they are, now we found out that there's something special called linear pairs. There's one more thing that I want you to talk, or that we're going to talk about, another identity. You've already learned complementary angles, supplementary angles. Now you've been introduced to linear pairs, which are just supplementary angles that are adjacent. The last thing is vertical angles. Vertical angles are angles whose sides form two pair of opposite rays. And what that basically means is they are opposite. We're going to write right below it, opposite angles. Okay. You can always identify vertical angles because they are opposite each other. Angle 1 and angle 3 are opposite each other. So angle 1 and angle 3 are vertical angles. Also, angle 2 and angle 4 are opposite. They're pointing in opposite directions. That's what it means when it says their sides form opposite rays. If we take these two lines that intersect, and this line is going in this direction, this line is going in this direction, this line is going in that direction, opposite direction, obviously we can see that they're opposites. Okay, they go in opposite directions. But again, 2 and 4 are vertical angles. Note down here, very, very important, very, very important, very, very important. Vertical angles are always congruent. And can you tell why? We're going to discuss why. This is going to be one of those things that you're going to figure out more on your own. We're just going to, for now, let's just stop at the fact that they are always congruent. Meaning that angle 2 is congruent to angle 4. And again, what does congruent mean? Congruent means the exact same. If angle 2 is 125 degrees, then angle 4 is 125 degrees. If angle 4 is 130, then angle 2 is 130. They are exactly the same degree. Same thing with 1 and 3. 1 and 3 are congruent. And again, you'll figure out why as we go through this. That's going to be one of those things that I want you to discover rather than just me tell you. Let's look at some guided practice. Identify all pair of vertical angles and linear pairs. We're going to identify the vertical angles in pink and the linear pairs in green. Vertical angles, angles that are opposite each other. I'm going to give you a hint. There are 3 pairs of vertical angles here. Hopefully you're saying, well, opposites. Opposites. Let's start at 1. What angle would be opposite 1? And I hope that you can recognize that 4 is opposite 1. Well, then let's go to 2. What angle is opposite 2? Hopefully you can see that 5 is. And then the same thing with 3. What angle is opposite 3? Hopefully you see that 6 is. We could go through, and when it says identify them, we actually want to write them out. So we could say angle 1 is congruent to angle 4 because they're vertical angles. Angle 2 and angle 5. Angle 3 and angle 6. Those are all vertical angles. Now let's go through and identify linear pairs. Let's go back and identify what linear pairs are. 2 adjacent angles whose non-adjacent sides are opposite rays. Again, what that means, 2 angles that are supplementary and adjacent. Do we have 2 angles, let me switch colors, 2 angles that are supplementary? Well, let's go through. Are 1 and 2 supplementary? Doesn't look like it because remember, supplementary is 180. 180 ends up being a straight line. Well, let's check 2 and 3. 2 and 3. Are 2 and 3 supplementary? No, again, not a straight line. We can actually kind of fast forward a little bit and see that we don't have any 2 angles, okay, that add up to 180 degrees. Now they're all close, but no 2 angles here, and again, they have to be 2 angles. No 2 angles add up to 180 or form a straight line. And another way that you might want to do that, especially when on your homework tonight, find a straight line. There's a straight line. Are there 2 angles on both sides? No, there are 3. 1, 6, 5, that's 3 angles. 2, 3, 4, that's 3 angles. Well, find another straight line. 2, 1, 6. Nope, that's 3. I'm looking for 2. 3, 4, 5. Again, I'm only looking for 2, and there are 3 there. You can see that we don't have any linear pairs in this diagram. Let's go to the next one. Find the value of x and y. Little note, JKM is a straight angle, and WXY and TXZ are vertical angles. So over here, we're told that JKM is a straight angle. Hopefully you can remember what a straight angle means. A straight angle means adds up to 180 degrees. We talked about the 4 different types of angles in the last section. Let's kind of back up real quick. And here we have straight angle equal to 180. So let's kind of fast forward again. Oop, too far. There we go. If JKM is a straight angle, or it adds up to it's 180 degrees, what does that tell us about angle JKL and angle LKM? If the whole thing is 180, what does that tell us about these two angles? And hopefully you're saying to yourself, well, those two add up to be 180. That's the angle addition postulate. Angle add post tells us that angle JKL plus angle LKM equal angle JKM, and I know I'm running out of space here. That's the angle addition postulate. Well, they told me that JKM is 180, so I can replace that. I can replace JKM with 180. Then they tell me that JKL is 5x, and that LKM is just x. Well, here I have an equation, but just by replacing what I already had. Notice I had to use the angle addition postulate to even set up my problem. That's where I had to start. Then I replaced everything with information they gave me. They told me that JKL was 5x, so I replaced JKL with 5x, or I substituted it. LKM, they told me was x, so I substituted x for LKM. They told me that JKM is a straight angle. I already knew that a straight angle meant 180 degrees, so I substituted 180 for JKM. Now I have an equation that I can solve. This is where your algebra kicks in. Notice so far we've been using geometry. Now we're going to use the algebra we have to solve the geometry problem. 5x plus 1x gives me how many x's? 6. That's just simplifying. I'm going to drop down the 180 because I didn't do anything with it. And now I need to simplify this. 6 times x equals 180. I don't care how much 6x equals. I want to know how much 1x equals. So how can I get rid of this 6? Right now it's being multiplied. How can I get rid of it? Hopefully you're saying in your head, divide. So let's divide both sides by 6. Remember what we have to do. What we do to one side, we have to do to the other. When we do that, the 6's cancel out. We're left with x equals. And on this side, 180 divided by 6. Well, maybe you're not very good at that. Let's grab our calculator. 180 divided by 6, 30. Bingo. Now it told me find the value of x, so I'm done. Okay, I found out x was 30. But just understand, you might have to plug that in. If they told you to find the angle of JKL, you would have to plug in the x into that angle and find out 5 times x, well 5 times 30, that means that this angle is 150 degrees. Just understand, although you solved for x, you might not always be done. Let's go into the next problem. I'm going to erase this just so that we've got enough room here. Of course, I'll write the answer below it because we did solve it. X equals 30. Good job, class. Whee! All right, next. WXY and angle TXZ are vertical angles, meaning these two angles are vertical angles. Does anyone remember what I told you about vertical angles? Let's back up. Vertical angles are always congruent. Well, if they're congruent, let's write that. WXY is congruent to TXZ. Awesome. Just like I replaced my values over here, I'm going to replace them over here. I'm going to say that instead of writing WXY, like I did, I'm going to substitute what WXY equals. 3x plus 30. And I'm going to do the same thing with TXZ. I'm going to replace it with 100 minus 4x. And I know that you might not be able to see that. Let me rewrite it over here. 3x plus 30 is congruent to 100 minus 4x. There, now you can see it. The only problem is that this little symbol right here is a congruent symbol. That's geometry. In algebra, we have something that we use when two things are the same. It's an equal sign. So we're going to take out that congruent because we're basically all in algebra form right now anyway. We're going to switch out the congruent for an equal sign. That helps us solve it. 3x plus 30 equals 100 minus 4x. Now I need to simplify this. I want all my x's on one side and all my non-x's on the other side. We're going to move this negative 4x to the other side. We do that by adding 4x to both sides. And watch, without simplifying, we're going to do another thing. We're going to move this 30 to the other side by subtracting it. We're going to do all of that in the same step. This helps us simplify it faster. Well, when I take 30 and subtract 30, they cancel out. When I take negative 4x and add 4x, they cancel each other out. And so what I've got is, now I can simplify. 3x plus 4x, well, if you have 3 of something and you add 4 more, how many do you have? 7, good job. We drop down the equal sign. 100 minus 30, well, maybe you're saying, I can't remember. 100 minus 30, 70, sweet. Now we can simplify this. 7 times x equals 70. If I want to get rid of that 7, how do I do that? What is the opposite operation of multiplication? Correct. It's division. When we divide both sides by 7, this side cancels out. We're left with just x. 7 divided by 70 gives us 10. We are done. Now remember, we're only done as long as the directions tell us to just solve for the value of x. If they ask for angle WXY or angle TXZ, we would have to plug in the x into those problems and find out what exactly they equal. But they didn't, so not a big deal. Hopefully you understand this. Hopefully you can figure, you know what complementary angles are. Let's actually write this on the next page because it's your turn now. Hopefully you know what complementary angles, supplementary angles, vertical angles, linear pairs. Hopefully you know what those 4 things are because those are the different identities that we dealt with today. But then hopefully also you're able to use algebra to solve for missing parts, just like what we did in the guided practice. Hopefully you can use your geometry to set up a problem, then you can use the algebra to actually solve the problem. Let's take a look at your homework now.